Hi, I Ankit Mishra, project lead of the Power Grid team. I'm going to deliver a presentation on analysis of load shifting along with my teammates Mr. Veen Dao and Mr. Kunal Rajput. Nuclear, hydro, and gas power plants provide base load to the power grid. Wind and solar are additional seasonal components. The base load in the grid looks like a step function. That is, it has no variation with time. The seasonal components give more or less a sinusoid of a certain frequency, which depends on the weather conditions. If you see a typical load curve, it can be visualized as a load following sinusoid clamped with non-varying step load. In this diagram, you can see the variation is huge, that is of the order of 5000 megawatt, which is clamped over a step function of 10,000 megawatt. This document will broadly cover load analysis of the existing power grid in the New England region, where we'll try to identify few issues with the system. This would be followed by general idea of what can be done to mitigate and later on develop this idea into a concept. The next step would be to objectify the vision that broken down into smaller and easily achievable pieces. Steps for the analysis of the preliminary concept would be laid down. Here on, we would be more focused on executing the project based on the detailed document created in the previous steps. The other sections would cover data collection and its status updates, discussion on storage technologies for realization of the concept, comparison of these technologies in order to identify the most suitable tech for our needs, and in the last section, we shall discuss the project progress and the milestones. Vision of our project is to de-stress the grid. Typical power grid works by matching the generation, generation to the net utilization in real time. Grid always keeps extra generation capacity handy in order to have greater control of the S&D curve, that is the supply and demand curve. This additional real-time generation capacity helps in maintaining and ensuring availability at all times. In case of New England, approximately 60% of the electricity comes from burning gas. This is to an extent load following in nature, as the engines can be started and stopped quickly without significant performance or life degradation. The problem associated with this technology employing load following methodology is the fuel prices. The fact that the fuel prices go up with increase in the demand. There are other methods to curb this instantaneous inflation through long-term contracts and agreements between the relevant stakeholders. Our focus in this study would be experimenting another methodology, that is flattening of the generating curves to de-stress the grid and also thus hitting the objective of keeping the prices in check. The fundamental idea is using the time when the demand is low to store energy and then use the same when the demand rises. In figure number 1, we see a general case of a sinusoid. Figure 2 shows point of generation. Please note that the gap between the actual mean of the cycle and the generation rate marked by the dotted lines is due to the inefficiencies of the technologies, including reproduction inefficacies. Figure 3 depicts the case of shifting of the load. The area under the curve shaded would be, for example, the charge stored in case of batteries. This is shifted in time axis and used during the next cycle when the demand is higher. Figure 4 shows plotting of the linear de-stressed power grid generation, which takes into care smaller adjustments owing to the unexpected increase or fall in the energy demand. The curve is flattened, thereby reducing the need for higher generating capacities and ensuring better utilization of the resources. You can have a look at the flattened curve here. This is the flattened curve. The smaller variation is due to the instantaneous or the actual net increase or decrease in the demand. Identification and documentation of the objectives. These are sliced into three parts: technology, economics, and policy. The policy objectives are very straightforward. That is, they are related to the subsidy encouragement. Objectives of the technology aspect is to identify the storage technologies, to find effectiveness of the load shifting using particular methodology or a mix of technologies to define a parameter or a method for calculating the efficacy of the load shift. The economical aspect, find the cost of the load shifting, then to find the cost of the shifted energy per megawatt, to find the cost of shifting energy per megawatt hour, that is in dollars, as well as in energy required for shifting unit energy. Then to find the increase in the cost per unit of electricity or the averaged energy mix price. Methodology. We would be following data approach to problem solving. An excellent understanding of the generation curve along with the present utility scenario and some extrapolation is required. These patterns, averaged over seasons or any other classification, can be easy to map, but at the cost of some granular noise. There is going to be a trade off between the complexity and the granular noise. If one goes for averaging over weeks, months, seasons, or years for achieving a simpler fit, then the daily variational details would be missed, and vice versa. The analysis of this methodology of load shifting is done in the following steps. Step number one, collection of the data. Step number two, understanding the load curve. Step number three is analyzing the potential method for the load shifting. Note, step two is partially completed. Step number three is almost complete, and we have selected storage systems for load shifting. In the intermediary steps, we shall download data pertaining to EVs, consumer charging behaviors, through public domain survey reports and other related documents. This can be this can form a very good use case for load shifting project. Like for example, case 1, where the actual demand due to rise in the EVs is significant figure, then we shall try to negate the effects using our storage system analysis. On the other hand, if the increase in the load burden is not significant, we may use a stream of hypothetical data or scenarios to prove our case. Thank you.